So welcome in the session of DBMS. Today we will discuss about Unit 2, lecture number 5, and the topic which I will discuss is relational calculus. The content for the lecture are introduction of relational calculus, tuple relational calculus, domain relational calculus. So we will discuss one by one what is relational calculus and what are their types, what are tuple relational calculus and domain relational calculus one by one. Now introduction of relational calculus. So relational calculus is a non-procedural query language and it uses mathematical predicates calculus. In relational calculus, a predicate is a truth-valued function with certain arguments. When we replace with the value for the arguments, the function produces an expression. It is called proposition, which will be either true or false. So the relational calculus tells the system what data to be retrieved, but it does not tells to the system that how to retrieve that data. So that's why it is non-procedural. So relational calculus is further subdivided into two major relational calculuses. One is tuple relational calculus and another is domain relational calculus. So you could see here the relational calculus in figure has two subparts, tuple relational calculus and domain relational calculus. So when we applied it to the database, we found it into two forms, tuple and domains. So tuple relational calculus was originally proposed by E.F. Code in year 1972. However, the domain relational calculus was proposed by Lacorix and Pirotte in the year 1977. It is discovered after the tuple relational calculus, domain relational calculus has been advised. So first of all we will learn about tuple relational calculus. It is also called TRC. The tuple relational calculus is specified to select the tuple in a relation. In TRC, filtering the variable uses the tuple of that relation, and the result of the relation can one or more tuples. Okay, so the notation for the tuple relation calculus is shown here in red letter. T is here resulting tuple. T denotes the resulting tuple, where PT denotes the condition. So T consists of PT. PT is condition used to fetch tuple T, or we could write it T condition of T, where T condition of T. For example, we will take example T dot name, tuple name, where author which is belongs to that tuples and author is the relation, and T dot article means tuple article is equal to database. So we could find the output from this query. The query selects tuple from the author relation and it returns a tuple with name from author who has written an article on database. So continuing the same tuple relational calculus, in TRC we can use existential and universal qualifier. The symbol for existential and universal quantifier is like opposite of E and V with opposite of A, universal quantifier. So for example, R is the tuple where there exists, R is the relation where there exists a tuple T that belongs to the author, where T article equal to the database and R name, relational name, is equal to the tuple name. So that is representing the same thing with certain symbols. So this query will again yield the same result as the previous one. To express the query, find the set of all tuples S that function of S is true. So we can write it as a condition of f S is true. We can write it as like S where in relation Fs. Let another example to express the query. Find the staff number, first name, last name, position, date of birth, salary and branch number of all staff earning more than 10,000. So this is this all attributes belong to the staff relation. So we can write S is such that where staff is in relation of S, and there is a AND operator, and S dot salary is greater than 10,000. And you could also write one more example. T is the tuple where T represents a tuple, small t, and it belongs to the relation teacher T, and the T dot salary is greater than 20,000. It implies that it selects a tuple from the teacher in such a way that the resulting teacher tuples will have salary higher than 20,000. This is another example. Now coming on domain relational calculus. Domain relational calculus is also known as DRC. The second form of the relation is known as domain relational calculus. In domain relational calculus, filtering variable uses the domain of attributes. So their tuples are filtered and here attributes are filtered, and domain of attributes are filtered even. The domain relational calculus uses the same operators as tuple calculus. However, it also uses the connectives like and, or, and not. The symbol of these three are given in your red ink. So it also uses the essential, existential and universal quantifier to bind the variable, like the notation here A1, A2, A3 and AN. These are the attributes that belongs to the P stand for the formula where the function of attribute. The formula of P is the function of that attribute A1, A2, An. So where A1 and A2 are attributes and P stand for the formula built by inner attribute. So continuing on the same concept, domain relational calculus. So you might see the first line, it is the example of the attribute article, page and subject which belongs to the book details relation and the subject is equal to database. So the output of this query is this query will produce the article, page and subject from the relational book detail where the subject is database. One another syntax has given like C1, C2, Cn where the function or formula f is the function of C1, C2, C3, Cn. So we could say where C1 and C2 etc represents the domain of attributes, columns, attributes or column, and f defines the formula including the condition of fetching the data. So one another example, for example name, find out the name and age. These are two attributes that belongs to the table student and the age should be greater than 70, where age should be greater than 17 years. So again the above query will return the name and age of the students in the table students who are older than 17 years. So these are two major concepts of domain relational calculus and as well as tuple relational calculus. So these all includes the relational calculus.